Now I will focus on the management of time within the Inception project, but I think it's a more general problem that, as Professor Leonidas say, give us the possibility to choose some standards right now to describe the time changement inside the cultural heritage assets. So, we have normally, when we talk about monuments and cultural heritage and assets, we think about 3D modeling for digitization. But we need always, in cultural heritage, and not in modern building maybe, to add the fourth dimension, the time. The time is different from the 3D dimension because it has a direction, could not be in both directions, and it is not so easy to capture in the moment that you are doing a survey. And we have a lot of points in managing the 3D models where time is very important, and we cannot skip the fact that we have to acquire and design it inside the 3D model. First one, acquisition. We have seen that several kinds of surveys are possible to understand the shape, the correct shape of the tree model, the monument, etc. Every acquisition has a time, a specific time. The monument can change between the acquisition time and the fact that we have a metadata related to the acquisition is mandatory. Other fact is about geometries, how, when we create geometries and to which model and to which time they are related. I'm reconstructing the monument at the beginning. I'm focusing on how it is represented right now. We have to write it somewhere. The documentation. I used the documentation to reconstruct the model in a certain time. I have also to write when the documentation was written, when I found it, etc. The evolution. We are not only talking about time as a specific point, but also like a time frame. And we use phases to describe it in the BIM. So, from this point to that point in time, how is the model? Because we cannot be second accurate to the second. So we have to understand how to describe the time passing on the model representation. Monitoring. At the time I attach some sensor or I describe the monument at a given time for understanding if it is changing, I have to choose a standard to attach time to the different monitoring documents, like sensors data or specific survey times, etc. And this goes to the management and maintenance. Also, on administrative and maintenance issues, intervention, restoration, etc., time is very important. We cannot miss this data in describe our intervention on the monument. And these are different points of view. If we don't have a general way to describe time, we cannot link them. We cannot really explain how the monument has evolved in time, how we managed it, etc. And if we use a different way of describing time, every part of the documentation will be scattered. And we don't have the holistic documentation of the previous presentation, which is our goal. In the framework of Inception, we choose to use the Semantic Web Standards as standard for BIM. Why we choose them? First of all, we need to trace the model as a semantic description. A column is not only a cylinder, but is semantically described as a column, etc. And time could be one of those descriptions that we can add directly inside the BIM model. Semantic Web Standards are, in general, a huge reference inside cultural heritage. We can think of Ljubljana, but also a lot of different European projects using semantics. But this was not really connected with the 3D representation and the BIM modeling. This is because it is not trivial. It was a big work inside Inception to find a way to connect the semantic standard with the BIM, passing from a database, a geometrical database, to something that is really describing in words the monument. So the needs to which with the answers in Inception is to represent all model components, not only time, through semantic. This allows us to also enrich the model with different kind of information, documentation, but not only. It's, the interoperability of the semantic standard allows us to do really interesting things. The other thing that the previous intervention said is that we cannot be dependent on formats. The semantic standards are interoperable by definition. And we can have machine-readable data if we describe it with ontology, with the semantic standards. And we can add, in general, documentation to the model. The Semantic Web Standards is our answers because it really, these are the goal of the semantic web, as you can see, is perfectly the perfect answer of our needs of the previous slide. It is based on ontology. We have different layers of languages. From the simplest, the RDF, from the more complex, the HOWL, which in really brief way, it's like we have a different level of relationship with within data. RDF is like we connect two different data. With HOWL, we can add rules to link data between them. And this is our main question. Okay, we have the problem of interoperability, of adding documentation. We have the semantic web that says it answers this problem. How we can do it? This is one example. We have a model. The model has more or less deep granularity. We don't have only one model, but we have the different part of the model. And the different part of the model could be attached with different information, can have different name in different languages. We have there the link with the Getty Architectural and Art Dictionary, and all the documentation that can be related to different time that are not the specific time of the modeling of the model. Maybe we can say that in this time frame, this document, which is found and classified at this time, is related to this part of what's found in this monument. Really, the cases are really complex. And this is enrichment. So we don't have only geometry, but we have an history. Navigating the model, entering the building in the 3D model, we already have a storyteller like this, because the documentation and the enrichment tell us the history of the building. These are the main components in inception of our ontologies to achieve this goal. So we have external files, images, videos, audio file, everything. And we have also ontology properties. We can write directly what we can take in this part of the building is about. We have the part that comes from the 3D modeling, the EFC part, which is translated in an ontology. We have our time ontology to define with a standard way time, and we have the possibility to link everything inside the model with the external linked open data, like Ljubljana assets, etc., or the Getty vocabulary. It is seamlessly linked in the model, only using the correct standard. As you can see, we have different sections, and this is like the layering of the ontologies. This is the schema from the previous slide. And this is which kind of ontologies we have already used. As you can see, it's not like writing h-BIM ontology, but using the fact that the ontologies are interoperable to link different ontologies, external, defined outside inception, Ljubljana, Carrare, Getty, etc., all time, which is a W3C standard, so we didn't invent it, and other ontologies that are project-dependent. Some project needs external documentation, some project not, and we can choose which kind of ontology we have to add to the project.
You have to conclude.
Yeah, but it's at the end. Okay. This was one of the previous standard before inception. This is the time modeling in CDOC CRM, but we chose not to use it, but to use the whole time ontology. I think we are the first one to use it inside a 3D modeling project, because it's from 2017. And with this kind of standard, we constructed the time machine inside this Inception platform. I think that will be really well explained in the next talks. And cultural heritage needs time machine readable time.